So first, I'd like to apologize. I am not Brian Kelly. I'm trying to grow my hair out, but I am not Brian Kelly. I'm Eric Eilertson. I'm a hardware security architect at Microsoft.
And I'm Alex Tzonkov, a security architect at AMD.
Let's go ahead. So we're going to be talking about what can we do here to try to improve the hardware and firmware security supply chain. So I think we got a little build here. So right now we've been working on, many of you have heard about Caliptra. This is an open source root of trust for identity and measurement. So this is available now. People are integrating this into their parts. So you're going to start seeing these showing up in CPUs, GPUs, NICs, and this gives us, at runtime now, we can have high confidence. We are talking to the device, we have the identity, and we can start figuring out who this is and who made this device. We're starting to build up there. Now from that, now we have, we're adding some structure to the device attestations and claims. So we've got, different RIM files, co-RIM. We also have the SBOM files that are coming in when part of it is being delivered to us. Then go forward a little bit more here. So we've got, and now when we have these, we also have you've heard about last year, the SAFE program, Security Appraisal Framework Enablement. This is essentially trying to bring in third-party security audits to the firmware that accompanies these devices. These are the devices that give you the foundation upon which the rest of your software stack is built. I kind of like to say a little bit of this is, secure boot and attestation tells you you're running the code you want to run. SAFE gives you some assurances that there's reasonable quality code there. It helps you find some of the bugs and security issues. So now we've got on the left side here, we're kind of bringing up the identity and the runtime measurements that we can bring up and show those to users, whether it's through a RIM file or some attestation services. We can compare that to the RIM file the vendor published, along with the SAFE reports, and have high confidence in the firmware that we're running is running on a genuine device. But a little bit of this is, so what's missing here? So some of that is going to be, let's go ahead here, the orchestra. So how do we have some standardization for this? How do we move the devices? How do we move the evidence around? How do we publish this in a standard way? How do we have a standard ledger, for lack of a better term, an append-only ledger for putting life cycle events? When a chip is made, who made this device? Attest, yes, I made this. Perhaps you put the date and time, location for where this was made. As it moves towards integration and assembly, you might want to have another record there putting down what's happening so you can track this through. But important here is we need this to be transparent. We need this to be publicly available and know that this hasn't been tampered with. So we need some strong assurances there on this ledger. So here's a little bit of how this might work in action. There's a lot of moving parts here, but each one is there to try to provide some strong assurances about each step in there and trying to have multiple entities verifying each step along the way. So if we start up here kind of on I guess in the center there at chip manufacturing, when the manufacturer produces the chip and it has Caliptra inside of this, you've got a strong identity, the IDEV ID, of what is this chip and what's its unique identity. That request can be sent off to the manufacturer where they harvest this and have the public certificates of every device that they've made. They can use this to keep track of their parts, their supply, their warranty, and who they're going to be selling this to. That's where we're kind of building up and starting the tracking for this. When this moves into board assembly, this is where they can start adding on to, for this board, it has this CPU, this memory, these NICs, the BMC. What are the various components going into the board? Building up your both software and your hardware bill of materials. And then this goes into system assembly. Now these servers are assembled into a rack. I'd like to know which servers and what are their parts and where are they in the rack the entire way through. Then when this moves into, it's delivered to the data center, I want to be able to check, get an attestation from every device in there. Is it the device I expected? Is it in the location I expected it to be? Running the software that I expect it to be? And then I can move this towards testing and then finally into production. So now as we're moving through these steps, we've got some different signing services and ledgers recording every step along the way here. Who had access to it? What were they doing? What was the step that what operations were they performing? So we have a little bit of auditability here throughout the entire life cycle. But okay, here's a little bit more.
Sure. So what about the hardware supply chain security? So I know Eric alluded to that a little bit, but there are a lot of concepts tied to hardware supply chain security, from the hardware threats, device identity, all the way to life cycle and the circular economy. And I think a little bit later on you'll hear about how OCP Lock is helping with that circular economy in the hardware security space, right? So hardware security threats, there are real. Now we know that they're not as likely or as easy to do as a firmware attack, but nonetheless they do exist, and we need to figure out a way to mitigate them. And most of the ways to mitigate them is to strengthen that supply chain security of the hardware going out of the through the manufacturing process. So how can we trust that hardware, right? It starts with knowing what the hardware is and what the components in the system are, right? So that's where we have the concept of a hardware bill of materials. So many of you have probably heard of SBOM, many of you have heard of HBOM. So quick primer on HBOM. It's a concept very similar to an SBOM, but for hardware. It provides a framework, just like SBOM has a framework that describes all the hardware components and their relationships to each other. And having that HBOM allows us to begin addressing that hardware supply chain security problem, right? Knowing what's in the system, knowing what's on the chip, what chip you have, gives you that capability to start scaling and being able to address that hardware assurance. So here's that same picture that Eric went over earlier, but we've added the proposal that we should treat the hardware the same way we treat the software, which is create an HBOM and feed it through that same pipeline of endorsements and security that we are doing for the software, but do the same for the hardware. And at each level, as the hardware bill of materials starts off with the chip manufacturer, it goes down the pipeline to the board manufacturer, where they can build on top of that to describe what are all the hardware components on the board, not just that one chip, right? And then the same thing goes as the HBOM goes down to the system integrator. They can build on top of that HBOM all the way down to the data center, where once that HBOM, the hardware is deployed, you would have a record of what it is, where it came from, all the steps that it took to get to you to be able to verify the provenance. Okay, so with that, we have a call to action.
Yeah, we went through. So, the IETF SCIT proposal, it's a proposal stage right now in IETF. We need other parts of industry, the other chip manufacturers, board assembly, to engage, look at this, and contribute, fix some of the issues, identify the issues and help us find how do we fix this, so how can we move to a standard way to do this, so that all of our suppliers know what they need to do, and so that this is useful, not just for the CSPs, but for the enterprise. This needs to be useful for everybody. So we need to move the standard forward on this. So we need a call to action there to get involved in fixing this or addressing this.
And of course, there's also hardware bill of materials, right? So that spec came from CISA, so we need to make sure we're there to help influence where the specifications goes for HBOM, so that it can be as standardized as SBOM is. And then assess and figure out what are the changes that need to be done in the HBOM spec, so that we could easily bind it to that device identity that we have, as example, Caliptra, right? And then we need to kind of develop that overarching OCP security specification to comprehend the full supply chain security, not just from the firmware side, but both firmware and hardware together.
Yep, and the full integration and the full life cycle for that. How do I know that when I'm done using this device, have I removed all of the proprietary or trade secret type information so that I'm willing to reuse this, let this move on to the secondary market? So we need to address all of these issues in the hardware supply chain.
So with that, we're open to discussion.
Sorry, there's microphones to. Oh, okay.
Jeff's coming.
Thank you. So two basic questions, concerns. One is, you have all this information, what do you do with it? The NIST has this, CISA has this attestation form, but literally it's a piece of paper that you write your signature on saying that you conformed to. So all of this information from supply chain gets collected from semiconductor manufacturers through module assembly, through perhaps value-add resellers and systems integrators out through deployment, onboarding, use, decommission, resell. Who cares? Where's it all going in a way that is, 7 years from now is useful for something? And the second is related to the first. You care because NIST Secure Software Development Framework is now mandated under GSA purchasing contracts. So you must present this certificate of attestation if you want to sell to any federal government agency, and that went into effect September 2024. So how does this roll up into a useful attestation of compliance that's usable over time, and then, is this fully conformant to SSDF and the related EU Cyber Resilience Act?
Yep, so that's totally valid, good questions, good questions. So we, at least my thought is, we should not be inventing new formats or frameworks. Let's try to leverage what people are already building when possible, and let's identify, are there gaps to where we as a CSP want to go, as a cloud service provider, and can we extend that? Is it another layer we put on top or underneath? I'd like to do small augmentations to the things that we already have to be doing for compliance reasons, and how can we add that to improve the security that we want from a cloud service provider perspective?
So to add to that, right, your question about what do we do with all that information? Well, just like with SBOM, there's a mandate. I believe there is going to be, we're heading in the direction of maybe requiring a mandate for the hardware as well, because the vulnerabilities, there's vulnerabilities in both places, right? So with that, you want the end customer to be able to answer the question, where did this chip come from? Where did it, where was it created? Geolocation, so on and so forth. Depending on what the spec requires and what kind of information we get into the HBOM, it could be used to answer many different questions about the security and the assurance of that device. And if we extend our attestation frameworks to include HBOM and be able to verify and have the manufacturer endorse that, hey, this hardware is indeed the same hardware that my designers coded into RTL, right? Answering that question will go a long ways towards raising that bar of assurance.
The question was really, who gets that information in the end, and what do they do with it? Because if you're going to hand it to a government agency, do they just drop it into the file in the corner and it's done?
Right, for some of that, you kind of need it in two places. Some of it could come along with the hardware, but then I also need, maybe through public key signing, I could track this back to, yep, this was signed by the AMD public certificate, so I believe it. Or maybe I have to call out, talk to an AMD web server to say, I got this part, did you make this part? Is it still valid? Was it perhaps counterfeit, something like that? There could be an artifact that comes with, and perhaps optionally a real-time check. So.
Which is very similar to how SBOM works, right?
The whole point is nobody does anything with the SBOM after it's done.
So the question is, the problem is that nobody does anything with the SBOM once it's delivered, right? And I think that's something that has to change. Yeah. We have to use the information in the SBOM effectively to prevent the kind of vulnerabilities that we've seen happening in the software side.
So someone said SBOM, I think of that is the firmware, the software that is being delivered to me, I can check that. So as a cloud service provider, when I get firmware delivered to me, I can check its authenticity, check it with the SBOM, check it with the SAFE audit report, make sure that this code has been reviewed. And now Azure would be comfortable deploying that. But to our customers, they need to be able to come in real time at runtime every day, if they want to, and speak probably SPDM or something like that to talk to Caliptra to get the runtime measurements. So that I need to match that up to the RIM file, the reference integrity manifest file. And so it's slightly different hashes, slightly different spec, but we need to be able to handle both of those cases. But yeah, SBOM, and just like HBOM is kind of delivered and you're kind of done with it, but the runtime is what we need to be able to do every time.
And with SBOM, you have that very important open source relationship information, right? So this is where your, the log4js of the world, if that happens, you need to be able to answer, hey, I have a bunch of software in my data center. What parts of it are affected, right? And knowing that all the way from the firmware all the way to your OS and applications is very important. So we should not just drop it in the bin, right?
TCG is working on defining a platform certificate concept, which also includes some of these stages of supply chain. And how does the TCG platform certificate relate to like the HBOM concept? Because they seem like they're maybe doing two things solving the same problem, or are they different? Just want your take on that.
So I think they very well could be the same thing. I've only seen some of the work from the platform certificate, but it sounds like that's probably what we need. For my first skimming of this work, I've not looked in depth, but it sounds like it could be what we need.
And HBOM can be used to define that format and the schema just the same way as the platform certificate can, but we need to make sure that whatever specs, because we are driving specs and working with specs across different bodies, that we, at the end of the day, align on the implementation and we standardize across the industry on the way we're going to raise the bar of security assurance.
I have a related question. How do you make this whole attestation framework homogeneous across the whole ecosystem? Because, right, he told us we have a TPM, then we have Caliptra, and someone may use TPM code, or someone use EAT-based token. So how do you make this whole framework homogeneous in an ecosystem, a cloud service system where different devices are coming from different manufacturers, and they may be using different attestation mechanism? That is one question. Second question that I have, that you talked about that you have some way to, a ledger kind of thing, to store all the update that has happened, right? So are you talking about a blockchain-based approach, or?
That could be one way to do it, yeah. I mean,
Okay.
I don't need to be prescriptive in terms of what we do, but that would be one way. There's some nice properties there.
So I can try to take the first part of your question, which is how do we standardize, right? And we are all here because of OCP. And if we make sure that at the OCP we have specifications that the whole industry can follow, then you remove that bifurcation or each vendor doing their own way of doing it, right? So that's why we're proposing this here, so that it can be standardized and we could have a single homogeneous solution.
In the case of Caliptra, you have SAFE program. It has gone through SAFE audit, right?
Yep,
so there may be some other attestation mechanism that has not gone through the same certification, kind of any security certification. And when you introduce those kind of things in your system, how do you ensure the integrity of your platform as a whole?
Yep. Yeah. So that's one of that's where at runtime there, I'm going to want to look. When I get the runtime, when I get the hashes for what's running at runtime, I want to be able to match that up to the SAFE report. And if you don't have one, then I know there's a gap, and I may need to start looking at that. So at runtime, when I look at your RIM, the co-RIM or the runtime attestation, I want to match that up to a co-RIM file, and I want to match that up to the SAFE report. And if something's missing, then I know we're missing something. So
I think we have time for one more question.
On your call to action slide, the last bullet point there talked about expanding the OCP specification to cover supply chain and other areas. You guys want to preview any of the work that's been done there? Is that like just a twinkle in the eye, or are there actually stakeholders working on something? Or
I mean, so there's many different OCP specifications that are geared towards security. This is talking about putting them all together and building that overarching specification to put the whole piece, everything together that we have, right? We have the attestation architecture, we have obviously Caliptra and OCP lock, and there's a lot of specifications that are coming together. We're just saying that to improve the supply chain overall, we need an overarching specification for that. And I think with that, we're out of time, so thank you. Security project.